Hey guys, it's Vince. Today in this video we're going to be discussing grounding of your CNC system. Now I'm getting more and more questions every week on the topic of grounding, whether it be for components, whether it be for your system, and I feel doing a video now is totally justified because I want you guys all to be on the same page, whether you're a future client, past client, whether you're experiencing symptoms of EMI penetration on your system, such as ghosting, where switches and weird things are happening without you actually triggering anything, and also making you really aware of how prominent ground loops are in the CNC, regardless of how safe and how adequate we try to be with going over our system to make sure everything is done properly. So again, I can't emphasize enough, this video is going to cover the basic process. There's absolutely no way for anybody to really go over, your particular components individually. I mean, everybody's system is different. Certain components will require grounding at a different level. If you do have questions on specific components, of course, just message me. My contact information, again, will be at the end of the video. But overall, what we're going to be discussing is a star point grounding system. I'm going to just bring up a couple photos here for reference. A common ground point. So all we have here, you can see here we have outlets. They're all coming in. We have devices, whether it be computers, whether it be whatever it is, mainframes, all coming in. We have a compressor here coming in. Everything should have a central ground. Okay? If it's possible to match a single ground in your shop, you are going to be well ahead of the curve, so to speak. Now, this can be achieved numerous ways, okay? Typically, what you want to have is an actual ground, a star grounding point, okay? And a star point ground is real simple. All it is typically a bus bar. Now, you can have a bus bar either mounted on your chassis. You can have a bus bar mounted on your wall. I personally like to mount them on my chassis. It's typically up to the end user where you want to mount it. I mean, it's centrally located. That's all that matters. And again, we want to use heavy gauge wire as short as possible. Now, a grounding rod is mandatory to properly ground. If you want the best possible grounding solution for industrial equipment, a grounding rod is the best. Okay? The longer the rod is, they typically come in 4 to 8 foot lengths. I recommend the 8 foot if you can go that high. Again, installing it does take typically a professional, whether it be an electrician. You can do it by hand. I mean, there's some methods online that you can use with injecting water in the hole and whatnot. Again, if you have a concrete foundation, that may not always be the easiest thing to do. And again, depending upon where the actual rod is located, that's also something to keep in mind. Typically, like I said, they may not be the easiest to install personally yourself if you don't have the specialized tools. However, if you do have a grounding rod installed, you are rest assured to have the best grounding solution when it's done properly for your equipment. So it's definitely worth the time, whether it be the money to do it or you doing it yourself. And basically, guys, this is very, very simple. Grounding rod goes in. This can be outside your shop. It's an arbitrary picture wherever it can be centrally located. The closer the better. Typically they'll be outside the shop. You run a pass-through through your wall of heavy gauge wire. Again, 12 gauge and under is really the best way to go. The heavier gauge wire provides less resistance. The less resistance you have gives that ground more ability to flow current through, and that's exactly what we want to do here. Once it attaches to the bus bar, your bus bar then is acting like a breakout board. Think of it that way. And basically what we're doing is you can actually connect, to a lead to your CNC chassis, CNC controller, so on and so forth, to make sure that everything is isolated. Now, when I say you're isolating each component, that does not mean that you would redundantly attach, let's say, a lead to the gantry and also to the chassis. Okay, because then we're actually double grounding, which is known as a potential for a ground loop. Okay, you realistically only need to ground one part that is conductive. If your chassis is metal and you actually ground a piece of the aluminum chassis anywhere, if you do the base plate of the chassis and attach the bus bar to it, your gantry is going to be making contact, which will diffuse as well as where it would be naturally to the base plate. So you do not need to attach multiple grounds. If you do the chassis, it's all metal, you're good. The only time you would have an instance like that Where you'd want to isolate each component is if there's plastic or an insulator present, and then you'd want to insulate each individual component. Now, there's a lot of turmoil, I'll say, online as far as misinformation on ground loops, the potential for them. I'm going to say this. There are some actual disputes as far as you can ground on 2 points, and that's the best way to go, which you can do if you don't create a ground loop. Now, the potential of a ground loop when you do that is extremely high. So therefore, I recommend always grounding on one end. Okay, that's an old school way of thinking, but I'm telling you now that's the way to start. If you find you have no joy then, you can try grounding on both ends. It could make the problem worse. Once again, this is not an exact science to test, your particular application. You'll have to do some troubleshooting to find the best way. However, this is overall the proper way to ground as a base level. So when you're actually looking at this, this is the individual way to ground each component properly and isolate it from where you're definitively using an earth ground. Once again, the grounding rod is placed in the earth. Once Mother Earth has contact with that and it's properly placed, you run your gauge wire there to the bus bar. Once again, whether it's on the wall, on a central location. I'll show you an installation here real quick. Here you go. Facility central grounding system, real simple. Grounding rod right here. Here's his brass. All his leads are coming in. Boom, 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 boom. Okay? Everything feeds over. Now, again, I told you guys use the thicker grade wire or cable. Also make sure you keep it as short as possible. The shorter it is, again, we're reducing resistance. We want to get rid of them charges as much as possible and as fast as possible. So least resistance, that's all we have to do. We don't have to go into rocket science here, but you can definitely see through this image how it's done. Once again, grounding rod, all his ground leads. Some of these are bare, but you guys are getting the general image. Ground is typically green. Okay, so again, always keep that in mind as well. As you're wiring, you should have all your grounds green. That's the proper way to do it. Once again, best practice. So coming over here again, accessory leads, heavy gauge wire as short as possible. Very, very simple process. And again, it can be as simple or as complex as you want to make it. I've had clients ask me, can I have 2 bars connected as long as one lead is going to one component? Yeah, I mean, absolutely. If you need more than, let's say, 10 points on a bus bar and your bus bar only supports 10, you can mount another bus bar on your chassis or wherever centrally located you have it and use it to split again that ground. That's the whole idea. Okay. Other point, CNC controller chassis. Okay. If you shielded cable, you're going to have your ground drains. They should also be going to a centralized ground location. Now, many of you have seen in my videos what I'll do, depending upon how the unit is built, because once again, every chassis is different. The optimized way to do it is have all of your ground done in one area. Okay, if you're going to run a ground bar, which again makes sense because you're going to be using shielded cable. The only time you may not be using shielded cable is if you utilize ferrites, again, where you don't require shielded drains. So again, keep that in mind. Once again, ferrites don't necessarily replace proper shielded cable. They work in conjunction to give you the best effect. Okay, a lot of my systems now, what I'm doing, to give you guys an idea, is I'll use a tin braided copper. And if you use tin braided copper, guys, it's a sheath that basically goes over the wires. And if you make contact with, again, my chassis is conductive. It has an EMI conductive dip coating on it. It will dissipate all of the EMI potential that, again, any current that's going through to the chassis itself, acting as basically a bus bar, which saves me the time of mounting that, and they're all centrally located. Okay, but if you yourself are going to use a bus bar and you're not going to use tin braided copper, you again would use this process, once again providing the central location of one exact area for all of your grounds to be. Okay, now that may not always be applicable to your application. If you have a large chassis and you have components everywhere, some guys will say, well, I can have a shorter ground going on the left side of the chassis rather than the right. Common sense prevails. Mount a bus bar for a ground on the left, mount one on the right. You can do that as well. Okay, the main focus here is to keep one centralized ground for each shield. That's what you're trying to do. We never double ground. That's not best practice. Once again, you never double ground. That's not best practice because that can lead to ground loops, okay? Something else I wanted to point out, okay? This image is really interesting because it's dealing with audio equipment, okay? And I want to really make all my guys out there who are not familiar with audio equipment and ground loops. CNC equipment and audio equipment are very, very similar in the sensitivity to EMI and ground loops, okay? RF, there's different terminologies for it in different fields. Overall, what you see here, and this is really interesting, is you got a mixer and a receiver. You have a grounded plug-in here, and you have a grounded plug-in here. Okay. Now, of course, between audio equipment, typically shielded cable is used. So that's why I'm discussing this audio image, because it really defines what you may find with your own systems, depending upon what components we're talking about. So this is an arbitrary statement here. You can use it for your own process of elimination of going through your systems and hopefully isolating any ground problems you may have. You can see here, you technically have a ground loop present because, again, we have both devices connected and we have a ground here and a ground here. What we can do to diffuse this ground loop, and this is really interesting, is just connect a ground. Once again, to eliminate the hum, use a thick wire to connect the equipment grounds together. So if you use a large wire here, once again, reducing the amount of resistance for current to flow, if you do that, it will actually, the current will is optimized to actually flow through the thicker gauge cable rather than the actual shield, diffusing any potential of that ground loop. Okay, because you've given the ground less resistance, so it's saying, hey, you know what? Rather than go through this, which I have a bottleneck, I can go through this wire and everything is set. That'll help diffuse everything and stabilize your system. This method is to be used only on certain items. Once again, individual components that you may find you have ground loops present. That being said, controllers, whether it be your laptop, whether it be your desktop, computers always have ground loops. I mean, it's very typical. You'll find them on monitors. You'll find them on keyboards. You can have them on all kinds of connective accessories. That being said, when you attach controllers, USB controllers, UC100s, anything, if you're experiencing weird things, and when I say weird things, typically if you're running a UC100, we already know you got to change the cables out. The cables that come with them are really not the high quality kind of shielded cable you require. The weird thing about grounding issues is they once again can reflect themselves as noise issues. Okay, so I'm going to do another video discussing the UC100 or any USB device for that matter, as far as looking at ground loops, because I'm working on a couple different things to hopefully stabilize the unit to where it's absolutely perfect. Again, that's kind of hard to do because, again, dealing with EMI and noise and anything with grounding, it's always about stability and about how much of it you can actually attain. There's no such thing as perfection. We're always trying to get it as close as possible. So that being said, this right here, this application that you see right here with this method of using a thick ground wire in between the two units to dissipate that ground loop can be used on anything CNC related. The process is the same. It just depends on what unit you're working with. So let's say you find you have a ground loop on your actual PC, or you want to determine if you want to have a ground loop. Here's something you guys can try. Okay, again, trial and error is usually the best actual teacher, so to speak, as if you try things and you're not afraid to try things, as long as you're documenting what you try, you can always revert back if you find that it either gets worse or it gets better. 9 out of 10 times with grounds, if you use the processes outlined once again in the video, I'm trying to keep it as simple as possible, you guys usually should have joy. So again, if you're getting some weird wonkiness and you want to see if a ground loop is present, you can try this method. If you notice you have two grounds, anything that's connected to your PC and the PC is supplying power to an accessory, UC100s, Ethernet, possibly Ethernet smooth steppers, depending upon if you're using a converter, because they take 5 volts. So if you're using like a step-down DC converter to power from your computer's USB, you may encounter something like that as well. If you want to find out if a ground is causing the issue, all you have to do is attach a heavy gauge wire to, for instance, on a UC100, you attach a heavy gauge wire to one of the back locking screws on the DB25 backplate, and that would enhance the ground, once again, because you're using a large grade wire, and you connect the other end to the PC, the chassis, the actual metal case. Do it through a screw. That would help to tell you right away if you're diffusing a large amount of ground loop. Okay, if you're getting a lot of weird static, again, ground loops do weird things. They can fluctuate current up and down. Computers' current goes up and down. Anything can happen. These are things to really think about the more accessories you attach, especially guys with pendants. That's very possible too. I'm not a real big pendant fan in most cases because honestly, a lot of them have driver issues as far as if they're not made in the States and they're not really tested thoroughly for all applications, you may encounter driver issues. So what I recommend doing with them, if you're going to use a pendant, is sometimes look at the mini USB keyboards. It's easier to use that. Once again, you have full compatibility with Windows, full compatibility with your software, and you can basically just assign hotkeys to it and give you the same effect. Okay, wired device, USB. If you notice any noise from keyboards, mice, you can use this method as well. Once again, you do need a conductive surface. Typically, mice don't do it. Usually a ferrite will cover that, no problem. Ferrites, as far as keyboards, typically they're fine as well. It's when we start dealing with different gauge equipments as far as where they're connected. And once again, when we get into the shop, everybody's shop is different. Your environment may have a ton of equipment in there, not just CNC related. You may have other computers. You may have other equipment as far as saws, sanders. I've dealt with guys in full shop environments where they're perfect. You know, they don't have their system totally grounded this way, but they have no problem. Then I have other guys that have half the equipment, yet they have to do everything perfect in order to get there. It's the same thing, guys. You guys have to be willing to go the extra mile. This is not, again, a lazy man genre. You know, you really want to go in, do everything the best of your ability, and say, okay, I've done it. I'm the type of person, I'd rather do it right the first time so that I save time and money not having to worry about that when I'm getting asked about it. When I ask, like I said, either future clients or past clients or even present, you know, wherever we are in the genre as far as working together, if I ask you guys, is the system properly grounded? These are things you're going to want to look at, okay, and double check first. Because believe me, like I said, grounding is something that is so individual, especially not so much with the chassis, because when you come over here, you can see this is very straightforward. This is very straightforward. It's when we start coming over here that confusion can actually come up, because again, guys will look at this and say, well, there's a ground here and a ground here. You know, how are you going to, that's a ground loop, and they'd be correct. But if you use, like I said, this method with a larger gauge wire, you will eliminate the hum. And they're talking about the hum here, which in electronics, that's a ground loop. That's actually contingent of a ground loop. We don't hear the hum because our equipment, we're not listening to audio equipment, but same principle. So if you use the same process, you'll get where you want to go. Once again, I hope the video has been helpful. I'm getting a lot more questions on this, like I said, and I hope that, again, if you guys take the time to do this with your system, you're really going to see a huge difference. Another question that comes up quite a bit is about spindles and grounding. Guys, if you use this method to ground your chassis, and I've brought this up numerous times, depending on the substrate you're dealing with your chassis, what it's made out of. If you're using wood, which of course I highly, highly recommend you do not use wood. That's not the best application for wood. You're dealing with tolerance issues. You're dealing with expanding and contraction due to humidity and temperature. It's just a mess. I'm talking to the guys that are using metal chassis. When your spindle is mounted in a metal chassis and your chassis is properly grounded, your spindle is grounded because, again, it's conducted. Okay? If you're using a spindle that is not metal and is not actually, let's say there's an insulator there or there's something going on with your actual motor mount for the unit itself, then you'll have to look at isolating the ground point. The idea of proper grounding, when you're really wanting to, boil it down, the smartest way to do it, I feel, is to make it so that everything is grounded with as least wire runs as possible, unless absolutely necessary, because all you're doing is making more work. If you have the bus bar connected to the chassis, once again, the chassis is full metal construction. Everything that's metal construction and everything is making conduction to that metal chassis. Why run extra leads if you don't have to? Now, once again, there are exceptions to that rule, but I always say start with the least and then work yourself harder as required. It just makes more sense. It saves you time and it saves you money. So again, think in terms like that. It's purely logical. Once again, metal is all conductive. You can see here we got our copper grounding rod. It's the same principle, guys. If it's one ground is run, you're good. I also have questions on if a ground rod is not possible. If a ground rod is not possible, you can take the third prong. You can buy an outlet ground, it's known as. It's just a basic prong that goes in to your typical 3-prong outlet, and it just isolates the ground. I'm not even sure if Harbor Freight sells them anymore, but I believe they used to. And basically what it does is just lets you isolate your ground. You can run that and use that once again as a grounding rod location. It is not going to give you the definitive ground that you would get here. Some homes construction, typically that's your earth ground. Okay, you can buy an adapter once again to test that. You can have an electrician test that. Most of you guys are pretty electrical savvy to be messing with this stuff anyway, so most of you already realize that. If you don't, you can always ask. I would always, like I said, if in doubt, don't be afraid to get an electrician out there. A professional will tell you right away. And he may try to upsell you to a grounding rod because I'll probably bring up exactly what I did. But these are points that if you review carefully, I'm telling you now, you'll be golden. And again, you'll have a perfect starting point to get that new system up and kicking ass. That's what we're all here to do, make money and you know, have a stable system. That's what we want. So once again, guys, I hope the video has been helpful. If you guys have any questions, once again, my door is always open. It's storm2313@gmail.com. That's my direct email address. My eBay store is eDealers Direct Automation. It's actually eDealers Direct on eBay. They shortened it. So again, you'll have that link down below. And again, any questions that come up, I know there's going to be specific questions dealing with specific components, as I stated earlier. Just message me. I'll do my best to get back with you as soon as possible, and we'll get you taken care of. Once again, guys, thank you all for your support. Love you all. Take care.